let's get rid of this. And what I'm gonna do is I'm gonna start by introducing the problem from yesterday. The problem from yesterday was basically like this one. So most of you guys should have done this. So something called okay. So what I'm gonna do is I'm gonna talk about yesterday's problem first, and let's get rid of this. So yesterday's problem, we have a optimization. We have a 29.7 centimeter on the length and a 21 on the other side. So what happened is 21 times 29.7. We're trying to form a open top box by cutting off each corner, and this corner we're going to call it X, which is Ani did a very, very good job about the modeling. So you cut off the X. So the way you kind of think about it, whatever you cut off, if you fold it upward, that's going to become the height. So that's going to be height equation. So this is the height is because when you fold it upward, it's going to be H. Does that make sense for everybody? And then the width here is going to be 21 minus 2x because you're going to 21 going to subtract this x and subtract x when you fold it upwards. So it's 21 minus 2x. And then it's 29.7 subtract 2x. So this going to be here and take away 2x here. And that's going to become this equation that Ani come up with. So also when you talk about this part is we also going to talk about physical domain, right? So this is an example of a math domain. You might want to write it down. The math domain is going to be y equal to square root of x. My domain is going to be when x is greater than 0. So math domain is really easy to grasp because the x cannot be negative, so therefore it's going to say x greater than 0. Because when x is negative, you cannot square root a negative number. That's called a math domain. Now, what I mean by physical domain is different. Physical domain is what's available to you physically, not mathematically. Because mathematically, you can cut x any way you wanted to. You can x be 100, 1,000, it doesn't matter. But physical domain has some issue. Now, not the long side, it's going to be the short side. The short side of this part, 21, is the one that's the deciding factor. And I told students, if you guys take a chemistry, you guys should learn something called limited reagent. See, I said, yep, I learned that. So do you remember what's limited reagent mean? Okay, so if you have, let's say, you have a, I don't know, HCl and a plus, like, I don't know, an AOH, like this. And if this one is 1, this one's 1 mole. Now, if you have excess of this, if you have, let's say, 2 mole of NaOH versus 1 mole of HCl, the reactant is going to be NaCl, which is sodium chloride. That's only going to have 1 mole of it because this 2 is going to have excess. So, and this is called limited reagent. So you look at a smaller reactant, okay, small reactant, and that's going to be a limited reagent usually. So at this case, the limited reagent is going to be 21. So 21 minus 2x has to be greater than 0. And then you solve for that, x has to be less than 10.5. And you say, hey, does that make sense? What happens if I cut 10.5? If I cut 10.5, the paper is going to be like this. I cut off completely on this side, and I cut off completely on this side. And you cannot form an open top box. So that's why 10.5 is called a physical restriction, a physical domain, because a physical domain is going to provide you a resource that you can only use this much. You only can cut this much. You cannot cut more. Okay? You can cut as much as 10.5, but not 10.5. If you cut a 10.5, then you don't have paper left on one side, not even a string. Now what I did is I went to the Excel file, and this is my Excel file, and I plug in something. I use Excel. Those of you guys know how to use Excel. So I'm gonna use Excel. I'm gonna delete this. Sorry. I'm gonna delete. Shift up. Okay. So what happened is I delete it. And I go with this one is 1. I type in the bunch cutoff that I'm going to have. And I cut out with a 1, 1.5, 2, 2.5, 3, 3.5, right? And then 4. And then 3.5, I start using a small increment going up. And I use a formula of, do you guys have, how many of you guys know how to use Excel? You remember? Okay, so Excel can do the calculation for you. Do you remember that? Yeah. You just do equal sign and equal to 29.7. So let me see if I can make it bigger. Let's zoom in to maybe 200. So what I'm going to do is I'm going to do 29.7 minus 2 times the cell of B3. B3 is 1. And it'll automatically from 29.7 subtract 27.7. Do you see that? They do that for you, which is nice. And you can do that. You say that's typing more, but it's not. It's not typing more because I'm going to show you how to use things, tools from Excel. That's going to help you. So you got 21 minus 2 times B3, which 21 minus 1 is going to be 19. And this one just going to be B3 cell times C3 cell times D3 cell. You have to make sure you have an equal sign in the front. That's going to give you a 526.3. That's the value when your cutoff is 1. Am I going too fast? Now, what you're going to do is going to do this. And do I want to type this whole thing again? Is any way I don't have to type this whole thing? Do you guys know? Click and drag down, right? So you guys see this white cross, right? And you want this equation, you want to see this formula all the way down to every single thing. And I teach students how to do this because sometimes research people kind of need this. And so you don't want to type in the equation over and over again. So you can use, I call it the white Jesus and black Jesus method. You see that white cross? And as soon as the white cross turns to black cross at the corner, you see that? And so the white Jesus becomes a black Jesus. Then you just drag it down. And they do everything for you. So you see subtract 3, and it's 29.7. Subtract 3 is 26.7. And you see this. You're going to drag it down. So when on research paper, it's really help you because you don't want to retype everything. And you just drag it down. So I don't teach, only teach calculator, teach you computer. And this is the volume. And you see the volumes keep on going up as I cut more, right? If I cut more, I cut more. And then eventually you got about 4 point something. It's going to give you a maximum. Because after that, it's going to start coming down. And it start become negative at one point. That doesn't make sense. Because when you cut more than 10, then you're going to get negative area. So that doesn't make sense. So whatever your data, you should not take account into after 10.5. Because after 10.5, it's going to be 0. If you have a 0 as a volume, that doesn't make sense. You're not going to get negative value. And you say, oh, well, this volume is really big, 3,914. We should have used 20 instead of 4. The problem is that's already cut more than the paper. You have not enough paper to cut on both sides. If you cut 20 on each side, then you're cutting 40 inch, but you only have 21 inch, 21 centimeter, so you're not enough to cut. Any question this far? Okay, so that's pretty easy. So we're gonna use this one, so we got rid of this one. So we say, okay, let's go back. And Ani says, how do I do this? And I'm say, okay, well, let's just plug in the graphing calculator. 29.7, and that's we're gonna use calculator as well. So I'm gonna show you how to use calculator as well. So you're gonna practice with the calculator. At the same time, look at the decimals side by side. If you look at decimals side by side, and that's gonna be a lot easier. So those of you guys can share the calculator. Just gonna share today. So we're gonna show you how do I do it. Very, very important lesson today. So I have a calculator here on the side, and I have decimals. I'm gonna open on this side, and the way I kind of do calculator is I want to erase everything. So you can type it, you can write it down. If I want to erase everything, that means including all your Pokemons, all the Mario, Street Fighter that you have in your calculator, that is going to be erased. But sometimes you have to, because sometimes your calculator is not working out. It's not giving you the calculation you want. So you're going to do second plus 712 712. And if you do that, so second plus 712, they clear everything. So all your Pokemon is gone. Sean's like, no, I cannot play Street Fighter on that anymore. Okay. Second plus 712, that's just erase the memories. Erase the memories. Because sometimes you need it. And especially if you take stats, you have a stats plot, and that's where the calculator come in very, very weird. Every time you're graphing something, it's not coming out. You don't want to do that. So what I'm going to do is I'm going to go to decimals. I'm going to graph these functions. And then on the decimals, I can do it on decimals here. So then you got v of x. And that's what Ani did yesterday, right? Is equal to 21.5. I think it's 21 minus 2x. Is 21 minus 2x or what? I forgot. 29.7 minus 2x. Right? And times x. And then you technically got one line. All right? And you say, okay, what is going on? I think, Ani, you got this yesterday, right? You're like, oh man, what'd I do? And then you got this part, which is you so happy. He says, oh yeah, let's cut off 10.5. And then you realize after you cut 10.5, there's no paper left. And you say, there's another point. What does that do with it? Okay, well, obviously that you have the wrong graph, not in the right perspective. You have the right graph, but wrong perspective. So that just says, remember the output from Excel, right? So let's go back to Excel. The output is all the way to what? Around 1200. And this one, I go all the way to 20. So that means X and Y value need to readjust. So what I mean by that is I'm going to go to here, and I'm going to click on the window here. And I'm going to say the X, I like some slack room. I know it starts with 0, but I don't like to start with 0. I like to start with some slack room, which is -2, and to maybe 20. And that's to see that much better point of view. And we know by volume, it's going to be roughly highest around 1300. So let's just say do 1500. No, let's start with -400 to 1500. Then you got this beautiful graph. Now pay attention to this graph. after this part, after 10.5, the rest of the graph should be excluded because physical restriction kind of eliminate whatever here, because what happened is this graph gonna tell you any kind of value. If you click a little here, see if you got 1.75, it's gonna tell you the value is 802.375. Do you see that? It's really awesome because this can model any part of value, depend how much cutoff is. It's not even an Excel table. It's just like kind of like you can slide it back and forth to figure out how much volume I'm going to get. Here I'm going to get exactly 0. So at 10.5. And then after that, it's going to be negative. Doesn't make sense. You're going to have volume negative or super high because this is already more than you can cut. Are we okay here? Now, do you understand this? And you say, okay, how do I do that on calculator? Now, I'm going to show you on calculator. I'm going to do this. So I'm going to do, click on y equal to. Do you see that? Okay, Sia, just share her what happened. And you guys can both try it. Y equal to, and you're going to type in x parenthesis 21 minus 2x, right? X is right here. And 29.7 minus 2x. .7 minus 2x. Any questions so far? We good? Beautiful. And all you gotta do is a graph. And you got the same thing as last time, which is a vertical line. You see nothing. So obviously you need to change your perspective, right? Your perspective, you want to maybe zoom out a little bit, but you can do zoom out, but the problem when you click zoom out, it's not going to help you because zoom out, you can zoom out and you press enter, you zoom out more, you see extra 2 lines on the other side, but that doesn't help you. So we're going to change this window. This window is very, very important. So we're going to click on the window. Okay, you see that X min? I like to type -2 because I don't like to be at 0. I like to have some room to cut off. And do not use this subtracting sign because when you say -2, you got to use this negative sign here. So this is -2, right? If I use that subtracting 2, in your calculator, it's not going to work it out. In here, it will grab because the computer recognizes that. But in your calculator, it's going to show up domain error or something like that. So that's going to be a problem. So I'm going to say -2 here. And all the way to 20. X max. And X min, I'm going to do about -400 to 2000. And I'm going to press enter. And I'm going to graph. And I got this nice graph.
Okay, that makes, because I did FX derivative of x, and I got 4 points for that, like that answer. And I was confused as to why I got the answer.
Yeah.
I was sitting there going, how does that work?
Okay, so I know you guys have only one calculator, but one person did it. I want you to clear the memory, second plus 712, and let another person try to do it. Second plus 712, and let another person try to do it. So just make sure they know how to graph. And if you don't, you guide them through. So at least that way they have computer, they have calculator, they know what to do with it.
I'm very proud of it. The part that I didn't know, like, how to go, like.
Here, Elise, you cannot be proud of that.
Well, no. Well, yes, but no.
Yes, but no.
Yes, I know it's wrong, but I'm proud of it because I didn't pay for it. But it's wrong, so don't do it. I just forgot to return it.
It's just a secret that you forgot to return it.
Yeah, they never asked for it back.
Graph entry.
Why would I like that? back. But we don't
They can ask you back. You're in a different state.
Not this one.
Okay, Sia, do you know how to graph? Okay, Jackie?
Yeah, I forgot.
Okay, do you know how to change your window?
Window and then change it.
I'm just waiting. I have no idea. My old school is in Texas. So it's a long way. Unless they ask it back, I'm not going to give it back. And they give me money to send it to.
Okay, so now,
No, you can't see it.
now on Desmo, it's very easy to click on this point, right? And they will show you, but the computer are dumb, and it doesn't do that. So how is that gonna do to help you to find maximum? So how are you gonna find maximum on a calculator? So go ahead and get back to Sia, and then Sia is gonna find the first maximum. You should learn that in last year. You can find out a maximum by doing you click on the second, and you click on calc, and then there is a maximum button, and you're gonna do 4, the maximum. And what happened is you want this maximum, right? You want this maximum, right? So I want to go back and click on the maximum. I'm gonna say left bound. When I say left bound, it's gonna be left of this maximum. Okay, I'll wait for Whitney. Okay, and what you're gonna do is left bound. On the left, you wanted this maximum, right? So first of all, second, trace, and then you're gonna do maximum, and you're gonna go left side of this maximum. Are you okay? The release? Left side of this maximum, and then you're gonna click enter. And you see this dotted line? They told you from which interval, they're gonna look for the maximum. So you're gonna go to right here, and you're gonna click enter again, and they say, oh yeah, I'm gonna look at for the maximum between those two lines. And then they say guess. I don't know why the hell they do that. They want you to press enter again, so you have to press enter 3 times to get you 4.402. So you got a maximum. So the other person's gonna find this minimum right here. So you're gonna practice to find this minimum here, right here, so that you guys both have some type of practice. Do you know how to find the minimum? Which is second, trace, and find minimum. And that minimum should have been some 14 point something, I don't know. 12 point, 12.858.
No, but I held it.
Same thing, this one. Trace, and then you click 3, and then you do left bound, right bound, and then hit enter one more time. So on here, and then you press enter, and then now you have the left bound, so there's no
Is it good? See ya? Okay. The back table, everybody okay? Trevor, Ani? All right, so you can find this point 10.5 as well as this point. So that is called a 0 on the graph. So you're gonna do second, because most of the time you gotta find zeros. So second trace, a 0 here, and then you're gonna say, I wanna look at this 0 right here. I wanna bound it between those two cursors. So I'm gonna put left side of this, right side of this, and then you should be able to get 10.5. Do you see that? You can get 10.5, and you're gonna get the other one. You're gonna try to get the other one. You and your friends gonna try to get the other point here, roughly 14.85. See if you guys can get 14.85 using the 0 That means you're looking for the zero of the function. Very, very useful tool.
Wait, so what if there are 2 zeros in the interval?
Yeah, so that's why you had to set your left bound and right bound. So that's why you need to do it between here and here. You don't want to do it here to here. They automatic is going to give me the first one. They don't give you the second one, I think. If I do second trace minimum, not minimum, second trace 0. The problem of doing that from left bound all the way here and right bound there, because you're going to have 2 zeros, and I don't know what they will give it to you. They will give you the second one, they didn't give you the first one. That's a problem. So you have to figure out what is in between, and that's the one that you want to do. Are we okay here? Now what's nice thing is this, that we have a v of x. Now on decimals, you can do this so easy, so easy. And that's why I love decimals. Second prime of x. And you go like this, voila, you're done. They graph this derivative graph. Now let's get rid of this. Can you tell me where is the original function? It's a maximum.
4.042 and 12.85. No, it's just 4.042.
4.042, because remember, f prime of x went from positive to negative. Original function is a maximum. Do you remember that? Also 12.858 is from negative to positive. It's a minimum. Let's look at the original graph. Look. Look. Everything kind of clear out very, very thing. Also, look at this. Let's get rid of this. Also, look at where's the inflection point occur. It's right here, right? Went from decreasing, increasing. There was an inflection point. Look at the original function. Look at this point here, right here, right here. Oh, right here, right here. See that? Went from concave down to concave up. And really change around this region, about 8.45. Very, very useful. Not only that, you can graph double prime of x. They also told you the same thing, because this is a graph of double prime of x. So this double prime of x. Oops, my bad. And see how they cross the x-axis? Went from negative, concave down, to positive, concave up. Guess what? At 8.45. We just teach you this. You did it on the test. Hopefully you did well. A lot of points on this one. It's like 30 points. You are half of failing right now. Just got everything right. Of course you got, not gonna just get this question right. You should get every question right, right? So anyway, that's that point. Now, how do I do it in graphing calculator? So I'm gonna show you. You're gonna go y equal to. You're gonna go to y2. Okay, so those of you guys gonna graph, those of you guys have calculator right now, you're gonna graph y2, and then we're gonna graph the derivative. And the other party, like Whitney and Jackie, gonna do the second derivative of that. So I'm gonna graph this, I'm gonna graph the derivative. I'm gonna go to math, right? I'm gonna go to math 8. And then they're gonna say d to the d, well, d to the dx, derivative with respect to x. And then the function, I don't want to type this whole thing again. Too lazy. Too lazy. I'm going to just use vars. Look at this. Vars. And then you're going to go to y var and then function. And just typing y1. And this is going to be x. Always x equal to x when you're graphing. If you say x equal to 2, they give you an evaluation, what they will plug in 2 for you, and you get a horizontal line. So you don't want to do that. So you want to do x equal to x. And then what happened is you're going to click graph. And voila, you got a second derivative. Now for those of you guys who don't have calculator, I want you to graph the second derivative of the function. Can you do that? Can you graph a second derivative?
Where can you go?
You have to change the var to y2 because you're graphing the derivative of the derivative.
Yeah, but for just the first derivative, I put y1 with two parentheses around it, and it did like
Yeah,
that.
it's loads. It's
Oh,
kind
wait.
of loads.
Maybe it works.
It's probably slower, but it does work. It work?
No,
So what did I say?
it says like error. It's like are you?
Oh, this one. Okay. So with this one, you have to do. Remember, there's a dx. You remember this one? This one's not updated. There's some way to update this, but the way they do like y1, and you're gonna do comma. That means dx, d to the dx, right?
Still,
And then comma x.
how people play.
So x equal to x, like this. And then you watch, you click graph.
Yeah, I've seen TikToks about it, and like before that, and Instagram, like people playing with this. Yeah.
And then it's gonna graph the second derivative. You will have to do y1 comma x comma x. Yeah, sometimes you got older TI 84 plus. You have to do. They would only say n derivative, and you're gonna say y1 comma x, which is that's the very old calculator. And that calculator from a long time ago. There's a way to update it. I don't know how to do it. So, guys, I'm gonna show you how to graph second derivative, right? If I graph the second derivative, I'm gonna go to the third functions here, and I'm gonna go to math and 8, right? And I'm gonna do derivative, but I'm not gonna do derivative of y1. I'm gonna do derivative of y2. So it'll be var functions and then y2. And then x equal to x. And if you do that, you click graph, you graph the thing. And some people says, how do I go to vars? You're gonna click vars, yvar, function, y1. Oops, that's bad. Let me get rid of that. X. And you know what's so cool is this. If you decide, if you says, hey, what happened when y1 is equal to 2? Like, I want an evaluation, right? There's 3 ways to do it. I'm going to show you the first way. The first way is here. You're going to do it outside screen. So you're going to do second quit, and you're going to go outside the calculator screen. And when you go outside the calculator screen, you're just going to click vars, yvars, function, y1, and just put parenthesis 2. Just like math notation. Boom. 873.8. Right? And if I want the second derivative at y1, so I'm going to function y3, I think, or y2, and at 2. So if I do, this is a derivative of the function, I want, oh, that's the slope, 266. I can do a third derivative, I can do that. But here you can do, remember, average value, right? Average value is f of b minus f of a over b minus a. So in this case, I can do average value from here. I can do a functions and the y1, and let's just say average value between 4 minus var, y var function of y1 of 2. Do you see that? It's very useful. And then you're gonna divide it by 2. So I need another parenthesis. So I need to go to the front. I need to insert that parenthesis. Now, how do I insert? I'm gonna do second delete. Now insert a parenthesis right here, and boom, I got all that. and I'm gonna press enter. I'm gonna divide it by 2 actually. I'm gonna do FB minus FA over B minus A, 127.3. So easy, I can use calculator to do it. Now, what if I want to find out the first derivative and second derivative evaluation at the same time? Now, evaluation is very, very cool. Then you can click on the window. Oh, sorry, not window. Second table set, there will be 0, 1. This is a table set situation. They start with auto, ask. We're going to do 0, 1. But you're going to do second table. They give you value of original function, first derivative, second derivative. Everything is right there in front of you. You just have to click second graph. Second graph is going to give you a table. So the table is right there and have every single value you need. And you say, Mr. Ye, I want to know 3.14. If I want a 3.14, I'm going to go change the window. We're going to change the table set here. I'm going to change it from auto to ask. So if I change auto to ask, guess what? And go here, press enter. I'm going to go second table. I'm going to say 3.14, which is roughly pi. So that will give you a value at 3.14. You want a 6.28? That's fine. Is that pretty cool? So you can get all the value at the same time for original function, first derivative, second derivative. Remember that question, find the equation tangent line at inflection point? It would be so easy. You got y1, you got slope, you got x1, you're done. You just have to put an equation tangent line here. It's all 3 things here, right? You got original value. So you guys can try it. A lot of people try it, see what happens. And this is a very useful thing. So change the table set to ask. Change your auto to ask. And you can ask any value you wanted to. Okay, so Jackie, get a calculator.
Okay.
Okay. Facebook Marketplace. Or Goodwill. Goodwill has them. Pawn Shop. Pawn Shop, Goodwill. You just have to make sure the calculator turn on. Just bring full piece of battery with you. And then plug it. Make sure you turn on. Make sure you grab. Make sure you type in auto key. Make sure auto key works. Then it's fine. It's going to be like $30.
Okay. If they sell it at Costco, maybe you'll get it at Costco. I think they have it at Costco.
Yeah, but Costco is expensive too. I bought a Marketplace.
I